Students, the video is about a topic called as insertion sort, which comes under the subject analysis and design of algorithms. The subject code is BCS 401. This comes under the part 2 of the module 2 for ADA subject, and insertion sort follows an algorithm design technique called as decrease and conquer. Okay, decrease and conquer. See, it is very similar to divide and conquer. Most of you must be familiar with the technique of divide and conquer. Here, the list of elements are divided into two parts. Exactly two parts. Okay, in case of divide and conquer. Here, what we do is, okay, how is it different from divide and conquer? See, in case of divide and conquer, when we partition the elements into two parts, what happens is, mostly two sides also will have equal number of elements. Whereas if there are odd number of elements, then one side will have one extra element as compared to here. Whereas in case of decrease and conquer, you can divide the array based on your requirement. I want one side to have only one element and the other side to have 5 elements. That is also possible. And suppose I want to divide my array into 3 parts. That is also possible in case of decrease and conquer. Okay, see, in case of decrease and conquer, I can divide the array into the requirements as specified by me. Suppose I want to divide the array into 3 parts and then conquer, that is also possible. Okay, so I hope you have understood the idea. So that is the idea of decrease and conquer. Okay, dividing the list of elements as per the user's requirement. Okay, now let me take the example of insertion sort, which is used for decrease and conquer. See, suppose I have these elements. Okay, I'll take 10 elements. Not 10, I'll take 5. Simple example I'll take. Now, first is the idea. Okay, let us discuss the idea in brief. So, what happens is here, the division happens in two parts. But the thing is, when the division happens, initially, one side will have only one element. Rest of the elements will come in the other side. So, whatever first element we have, that will be considered as sorted and rest of the elements will be considered as unsorted. Okay, so this is how the division happens. One side will have only one element at the beginning and the other one will be all the unsorted elements. Now we'll assume that because we have taken only one element, we'll assume that automatically it is a sorted one. So rest of the elements are unsorted. How does the technique work? What it does is, first it will take the leftmost element of the unsorted list and compare it with the rightmost element of the sorted list. So 10 and 22 will be compared. 10 and 22 will be compared. So what happens is, when 10 and 22 is compared, we want to sort the elements. So 10 is in the unsorted list, but I want to bring it to the other side because I want to arrange it, right? So what I will do is, initially what I will do is, I will bring that 22 in the place of 10. Okay, remember, I will bring 22 in the place of 10. But if I do this directly, there is a problem. See, when I replace 10 with 22, okay, replace means for the value will get replaced, right? That means it will no longer exist. But you want the 10 to come in the place of 22, right? You want it to be like this. So what you do is, before you replace, okay, before you replace, you store this element somewhere in a variable. So that once you get the element into the correct position, then from that variable where you have stored, you can bring the element back like this. So this will be the list now. Okay. Now we will assume that two elements are sorted. Two elements are sorted. Now, how do you think the insertion sort works? It will take the leftmost element of the unsorted list and compare it with the rightmost element of the sorted list. 2 and 22 will be compared. You see, 22 should have been in the other side, but it is not in the order, right? You want to sort them. So what you do? 22 will be brought into the position of 2. Okay, rest of the elements to the right will be kept as it is. So in the place of 2, 22 will come. 2 will be stored somewhere in a temporary variable. Then again, this 2 will be again compared with the element which is in the next to the element that we have compared. See, initially we compared with the rightmost element. Then we take the next rightmost element. We compare it with that. And then what we do is, we bring it to the position of this 22. So 10 will come here. Okay. So this is 10, 22, 15 and 12. So this position will be automatically taken by 2. So 3 elements are sorted. Now let me explain for 4 elements. See, 2, 10, 22, 15 and 12. So first what will happen? 15 and 22 will be compared. Remember, 22 will be stored, 15 will be stored somewhere. So when I compare, I come to know that the elements are not in the order. So 12 will be here only, no problem. In case of 15, 22, in the place of 15, 22 will come. It doesn't stop here. Then again 15 will be compared with the 10. 15 will be compared with 10. Is it in the order? Is 10 and 15 in the order? Yes. So no change. 10 will remain here itself. Likewise, 15 will again be compared with the 2. No change. So 2 will remain here. And in this position, that element 15 will come. I will explain this with the help of an algorithm also. Let me do for the fourth, the last element here. Okay. Now again, see, first 12 and 22 will be compared. 12 and 22. So I'll put the position. This is first element, second, third, fourth and fifth. Okay. So 12 and 22 will be compared. We come to know that it is not in the correct position. So 22 will take the place of 12. Then again 15 and 12 will be compared. 15 and 12. When it is compared, we come to know that they are not in the position. So 15 will come here. Okay. Then 10 and 12 will be compared. They are in the order. So no problem. It will be here itself. Again, here 2 will be there. And this 12 will be placed over here. So this is the idea of the insertion sort. Let us look at the algorithm and then also do the calculation. Okay. See, the algorithm is, first part I will not write what it is, and first line is all about what the algorithm is, and the inputs are the elements in the array A from 0 to n minus 1. There is a statement about what the array does. Input is unsorted elements A of 0 to n minus 1 unsorted list, and the output I will get is the same elements but in the sorted order. Okay, so here see, if you remember at the initial stage, the element from here was considered as unsorted, right? So if I take the index, this is 0, this is 1, this is 2, 3 and 4. See, the comparison started from 1 unsorted list. So, first statement is for I equal to 1 to n minus 1. Because the 0th element, we assume that it is already sorted. Right? Next, you remember before I sort, whatever element is in the unsorted list, leftmost, I will store it in a temporary variable. So, A of I, because in this case, I am taking this one, right? The first one. So, A of I am storing it in a temporary variable called as P. Okay. So, I'll write it here again. So, 22, 10, 2, 15 and 12. So initially, this is 1, 2, 3, 4, and this is 0. So the array will start from here. The loop, sorry. So 1, then this one. So a of I. So I is at 1, right? So a of I is placed in V. Then we want to compare it with this element. So how do I relate? I have I, no? So with the help of I, how can I get this position? If this is 1, what do you think this should be? This is 0, correct? This is 0. But I is storing a variable called as 1, right? So we'll find that value with respect to I. So I want to get 0. So 0 is, okay, 0 is this position minus 1. So that position is stored at I. So I minus 1 is that new place called J. With this, I will get the index of this element. Are you clear? Now, let us do the comparison. See, when I do I minus 1, so if there is this comparison, see, if I'm comparing for this iteration, so if I consider this, first this will be compared. So this will be J, I minus 1. Next, this will become J because this also needs to be compared, right? Then this will be J. So this becomes I minus 1. This is I minus 2, I minus 3. Till where will you go? Till where can you go? So while you do the loop, this condition has to be checked. The J will move towards its left. So J can be only till the value greater than or equal to 0. And you are comparing the element of this with this, right? This element. So it is A of J if it is greater than V. If it is greater than V, what do we do? If it is greater than V, then we take this element and place it in this position, right? Okay. So how do I write? This is, what is this? Okay. So what is here? So you have to write, I am taking A of J and putting it in the next position, A of J minus 1. J minus 1, no, J plus 1, next position, right? Like, then once this is compared, 22 and 15, then 10 and 15 also has to be compared. So J has to decrease by 1. So J is J minus 1. Okay, this will come under the loop, these two statements. Okay. And once this iteration is done, then the last statement that I will have is whatever V is there, that will put into its right position. Because I told you, when we compare, we have put the elements into V. Now V has to go to its correct position. So V will go to its correct position. That is A of J plus 1, because I've decreased it, right? So it will be like this. I hope you have understood the algorithm. Let us do the calculation. See, in the model question paper, there is one question here. Design an insertion sort algorithm. So whatever algorithm I have said, that you will have to write. Obtain its time complexity. We'll do the time complexity. And they have given certain elements 25, 75, 40, 10 and 20. You have to do the insertion sort on that elements and sort the elements. Okay. So let us first do the time complexity, because the elements are anyways over here. See, this is the algorithm. So we'll do all the three cases. First, I'll do the best case, then average case, and then the worst case. Okay. So if you remember, we have to identify the basic operation. So out of these many steps, which do you think is a basic operation? The operation that gets carried out the maximum number of times. So if you remember, this will not happen maximum number of times. The comparison over here The comparison, because I'm comparing the elements, right? Then only I will sort. So that happens maximum number of times. So A of J greater than V, this is the basic operation. Okay. Now let us do the complexity for best. Okay. So C best of N is, so for this operation, okay, this operation I have this loop. Suppose I find it in the, if all the elements are in the correct order, then I is equal to 1, 2, because it says 1 to n minus 1, right? So n minus 1, number of times the basic operation will execute is 1. Now, how do I calculate this? If you don't remember and if you have confusion with this, listen to me very carefully. See, this is 1 over here. When you apply the summation, what you're supposed to do is check if what element, on what element you're going to apply the summation, is it there in this term? I have 1 in that term and the summation is applied on I. There is no I, right? So the formula is like this. So in that case, what you're supposed to do is, if the element on which the summation has to be applied is not found in the term, then it will be upper limit minus lower limit plus 1. See, the upper limit is n minus 1. N minus 1. Let me write neatly. The lower limit is 1. Okay. So, upper limit minus lower limit plus 1. So, it will be 1 and 1 will cancel itself. So, I'll get n minus 1. And if you remember, in case of time complexities, can you have a constant? If you have a constant, one is a constant, what are you supposed to do? You're supposed to remove only, if you're supposed to remove all those and keep only the main term. So here it is n. And for best complexity, the symbol is omega. So it is omega of n. Similarly, for average time complexity, C of average of n. Average time complexity. We will assume that, okay, we'll assume that, okay, when we compare, okay, on an average, when you are sorting the, when you are inserting the ith element, we'll assume that it needs to be compared to half of the already sorted elements before it. We'll assume that half of the elements are already sorted. Okay, we'll assume in case of average means what? Some elements are sorted, some elements are not sorted. We'll assume that half of the elements are sorted. So again, summation will be applied on I equal to 1 to n minus 1. And this time on the ith element, so I by 2, because average, right? So I by 2. So I'll take that half as a constant. So I will be left with I equal to 1 to n minus 1 I, like this. Correct? Now, how do you do the complexity? So, how do you do the calculation for the summation? See, I am applying the summation on I. Is the term also having I? Yes, it is having. So, in that case, what you do is, whatever term you have, the final term, that into its next term, okay, that into its next term will give you the will give you the summation. Okay. So see here, suppose I have it like this. Just a second, okay? Okay. So here it will be this term into next term. Suppose I have something like this. I equal to 1 to n on I is n into n plus 1 divided by 2. So one term into its next term. So n minus 1 is, so this will be n minus 1 into n minus 2 divided by 2. This will be the value. Okay. So what I will do is, I will, so this half is already there. So that will be there here. Okay. So yeah, like this. Then again, half into n square minus 2n minus n plus 2. Okay. So this is what you will get divided by 2. So it will be 1 by this into this. So it will be 1 by 4 into n square minus 3n plus 2. Okay, so you will get all this. Now, if you remember, again, you have to take the highest term only. The highest term is n square. So I'll take only n square. So it will be, because it is an average time complexity, it is, what is the symbol you have? Theta of n square. Okay, this is how you will do the average, the worst time complexity. This is very, very important. So C worst of n. We'll assume the elements are towards the end, or it is not present only, or if everything is unsorted, here it is not about searching. So everything is unsorted, so you will have to do a lot of sorting. So let's do the loop. So 1 is for I equal to 1 to n minus 1. Not only that, in case of worst complexity, suppose I have it like this. Suppose this is what I have to compare. See, now 10 is the unsorted list. So I will have to compare it with every element like this, right? Every element. In that case, not only I will be increasing from 1 to n minus 1. In that case, j will be decreasing, right? This statement, it will get executed maximum number of times. Not that, sorry. This one. Not this j statement. This one. Sorry, here. This statement. Because I'll have to move the j to the next position like this, right? So, like this. So, j also will go from 0 to I minus 1 and 1. 1, sorry. So, it is summation of I equal to 1 to n minus 1. The idea is, again, check if the element j is present in this term. No. So, it is upper limit minus lower limit plus 1. Correct? So this and this will cancel. So you will get summation of I equal to 1 to n minus 1 I. And this is exactly same of this part. See? So you will get the same value, that is, what is the symbol for worst time complexity? Big O of n. This, if you want to calculate, it will be n minus 1 into n minus 2 divided by, so it will be n square minus 2n minus n plus 2 by 2. This you will get. So, removing all the terms, you will be left with this. Okay. So, let us do the calculation now. The same set of elements I will take, which is there in your model question paper also, so that it becomes easy for you. What you do is, after you have understood this, you take your own set of elements and try to do the calculation. Okay. So, remember the steps are, for I equal to 1 to n minus 1, all the unsorted elements. Initially, we put that element in a variable called as V. Then if you want to check for J, then it is I minus 1. Then we do the loop. So while J greater than or equal to 0 and we want to compare the elements, so A of J will be checked with V. If so, then it would be A of J plus 1 will be assigned to, will be assigned with the A of J, and again J will be decreased by 1, and out of the loop you have the statement A of J, then the remaining place you will put the value V. Okay, let us take the same numbers. So the numbers are 25, 75, 40, 10 and 20. Okay, so pass 1. Elements are 25, 75, 40, 10 and 20. Let me write the index 0, 1, 2, 3 and 4. We'll assume that 25 is a sorted one, then 75 and rest of them are in the unsorted list. So it says we are here, okay. So for I equal to 1 to n minus 1. So last position 4. What are you supposed to do? Take the value of A of I and put it into V. So A of I is 1. So A of 1 is how much? A of 1 is 75. You take that and put it into V. Okay. That is done. Let us do the next step. Then we want to take the element in the sorted list. So J is equal to I minus 1. So I minus 1. I is right now 1. So 1 minus 1. So J becomes 0. 1 minus 1. So J becomes 0. Then while J greater than or equal to 0. What is the value of J we have here? What is the value of J we have? 0. So while 0 greater than or equal to 0 and A of J greater than V. A of J. J is 0, right? So A of 0, 25, is it greater than 75? V. Let us check. This will become true. 0 is greater than or equal to 0, but this becomes false. So the condition fails here. If the condition fails, we come out of this loop and come to this state. So what we do? In that case, we take the V and place it at A of J plus 1. J is at 0. So take V. V is how much? 75 and place it at J plus 1. J plus 1 means we are talking about this position, first position, but it is already there. So no change in the element. So the order remains the same. 25, 75, 40, 10 and 20. But the thing is now 2 elements are sorted. Let us go to pass 2. Okay, let me write the elements again. 25, 70, sorted list. 40, 10 and 20, unsorted list. And this is the order 0, 1, 2, 3 and 4. Okay, now we will be 40. So it is, for that you have to find the array. So array is from, for I equal to, now 1 is already in the sorted, so 2 to 4. So we take that element A of 2, that is 40, and place it at V. So 40 will be placed in V like this. Okay, and j will become I minus 1, 2 minus 1. So j will be 1. Let us do the while loop. So while, okay, what is a loop? J greater than or equal to 0. So 1 greater than or equal to 0, and compare the element of, here it is, see, a of j greater than v, a of j. A of j is 1. So 70 will be compared with 40. Is 70 greater than 40? So this also true. This also true. So it will enter the body of the loop. What is in the body of the loop? A of j will be assigned to a of j plus 1. So remember, a of j is 1. Now a of j plus 1. So a of 2 will get the value 70. Correct? After that, what do you do? J is equal to j minus 1. J is right now 1. So now if I decrease, it becomes 0. Again, the loop will execute the same. So while j is 0, so 0 greater than or equal to 0, and 25 greater than 40. So this is true, but this is false. So condition fails. So the control comes after the loop. So what happens here? J plus 1 will be assigned with V value. So what is V value we have? V value we have is 40. So that will be put into A of J plus 1. J is 0. So J plus 1 is 1. So here in this position. So A of 1 will be now 40. So by the end of this, it will be something like this: 25, 40, 70, 10, and 20. 3 elements are sorted. This is pass 2. So you'll have to now do pass 3 and pass 4. Let us do it. I hope you're not getting confused. So pay attention and listen very carefully. Okay. So pass 4, pass 2, sorry, pass 3. Pass 3, right? It's pass 3. The elements we have is 25, 40, 70, 10, and 20. So this is 0, 1, 2, 3, and 4. Okay. Next, for I equal to 3 to 4, take that value of I, that is 10. 10 will be assigned to a variable called as V. Correct? 10 will be assigned. Then J will be I minus 1. So I minus 1 means 3 minus 1. So J is 2. Let us do the condition. While 2 greater than or equal to 0, J greater than or equal to 0, and A of J will be compared with V. A of J. A of J means A of 2, that is 70, will be compared with V. So this is also true. This is also true. So what is the condition in the loop? A of J, that is A of J is how much? A of 2. A of 2, what is the value we have at A of 2? At A of 2, we have the value 70. So 70 will be assigned to A of J plus 1. So A of 3. At A of 3, we will get 70. Okay. Then J will be decreased by 1. Okay. Again check. While J as in this case, what is the value of J we have? 1 right now, because of the previous iteration it is 1. So 1 greater than or equal to 0, and A of J. J is 1. So A of 1 is 40. Is it greater than 10? Okay. So now this also yes. This also yes. So again, what will happen? 40, that is your next element, A of j. Okay, j is 1. So 40 will be assigned to A of, and j will be reduced by 1. Else. Again, check. While j greater than or equal to 0, so 1, so 0 greater than or equal to 0, and 25 greater than 10. So both are true and true. So what will happen? A of 0, A of 0 will be assigned to A of 1. So A of 1 will get the value 25. And next, J will now become minus 1. J is 0, now it will become minus 1. When you look at the next condition, it will fail because J is not greater than or equal to 0. Here J is minus 1. So this will fail. It will fail. So it will come out of it. If it comes out of it, what are you supposed to do? Put V at A of j plus 1. J is minus 1. So now j plus 1 means A of 0. A of 0 will get the value V. V is 10. So now you will get the elements like this: 10, 25, 40, 70, 20. This will be the list. Again, pass 5. This is pass 4. Pass 4. Pass 4. This is, I think, the simplest one. Not very simple because the element 20 has to be moved a lot of positions, right? So for I equal to, so this is 0, 1, 2, 3, and 4. So I equal to 4 to 4, last position only, right? So like that. Then take the last element, A of 4, and place it as V. A of 4 is how much? A of 4 is 20. So take 20 and put it under V. Okay. Then decrease j by 1. So j is, j is what? I minus 1. So j will be 3. Let us do the condition again. While j greater than or equal to 0, j is 3. So 3 greater than or equal to 0, and A of j, A of 3 is 70. It is greater than 20. Then what do we do? Take that 70 and put it in A of j plus 1. So A of 4. And then decrease j by 1. So j is 3, now it becomes 2. Correct? Next again. While 2 greater than or equal to 0 and j is now 2, so A of 2. So 40 will be compared with 20. So both are true. So 40 will be now placed at A of j is 2. So A of j plus 1 is A of 3. And j will now decreased by 1. So it become 1. Again, while j greater than or equal to 0. So 1 greater than or equal to 0 and A of j. So 25 greater than 20. 25 greater than 20. Okay, so yes. So in this case, if it is yes, what do we do? Take 25 and put it at A of j plus 1. J is 1, so at A of 2. And now j will decrease by 1, so j is equal to 0. While 0 greater than or equal to 0 and in the last case, it is A of 0. A of 0 is 10. So 10 greater than 20. So this becomes true and this becomes false. So it will come out of the loop. Out of the loop means what are you supposed to do? Remember, you have to take that value v is 20 and put it in a of j plus 1. So at 1. Okay. So I'm getting the order as 10, then 20, 25, 40 and 7. Like this. Okay. So if I have the elements 25, 75, 40, 10 and 20 at pass 1, at pass 1, 25 and 40, 75 will be compared and no swapping is required. So 25 will be in its position, 75 will be in its position. So 40, 10 and 20. In pass 2, this is a sorted list. Now 40 will be compared with 70. If it is so, then 75 will take its place. Then again 40 will be compared with 25. If it is not a match, then 25 remains here itself and 40 will come to this position. At pass 3, I'll write the elements again. So 25, 40, 75, 10 and 20. 3 elements are sorted. Now here 10 and 75 will be compared. They are not in the order. So 75 will take 10's place. 20 will be here only. Then again 10 will be compared with 40. 10 and 40, they are not in the order. So 40 will take the next position here. Then 10 and 25 will be checked. That is also not in the order. So 25 will come here and this remaining element will come to this position. In pass 4, okay, let us do the pass 4. In pass 4, 10, 25, 40, 75 and 20. Select this. Now 20 and 75 will be compared, not in the order. So 75 will take its position. Then 25 will be compared with 20 will be compared with 40, not in the position, so it will come here. Next 20 will be compared with 25. They are also not in the position, so it will come here. Then 20 and 10 will be compared. They are in the order, so 10 will be in its position itself. Then 20 will take its place. Okay, so we have looked at the algorithm. We have looked at the algorithm. We have looked at the 3 complexities. We have looked at the model question paper question also. So you can take up your own elements and you can do the sorting and